particle is projected horizontally from the top of a tower 50 meters above horizontal ground with a velocity of 20 meters per second. Find the horizontal and vertical components of the velocity of the particle and the speed and direction of the particle when t is 1, t is 2, and at the instant before the particle hits the ground. So overall, we know that we have this sort of situation where the particle starts off here, 50 meters above the ground, and it's fired horizontally, and we know that that was 20 meters per second, and then it's going to go through a path like so. So presumably t is 1 is some point here, and we've got to work out the components there. Now we know that throughout the motion the horizontal is not going to be affected. We've got an acceleration due to gravity of 9.8 meters per second squared. So in part A, what we want to work out is the vertical velocity at this time. Let's take downwards as positive, and so that is a suvat. Well, we know that t is 1, a is 9.8, the vertical speed initially is 0, and what we want is v. So that's going to be v equals u plus at. So v is going to be 9.8 meters per second. So we have, this one's the horizontal, which we know is not going to change. So that's going to be 20 meters per second, and then we've got 9.8 meters per second. So if we do that as a vector triangle, like so, and we call this angle alpha, then we can say that the speed, well, we'll get that just from Pythagoras because this is right angled, so that's going to be the square root of 20 squared plus 9.8 squared, and so we've got the square root of 20 squared add 9.8 squared, 22.27, giving that to 2 decimal places, and the angle alpha will be the inverse tangent of 9.8 divided by 20. So we just need to calculate that. So let's just make sure that we are in degree mode. And so we've got the inverse tangent of 9.8 divided by 20, and that gives us 26.1 degrees to 1 decimal place. Now part B is done much the same way. So it's a suvat, it's just that t is 2 this time. So this is 9.8, we really want that. We know initially the vertical velocity is 0. So we've got v equals u plus at. So that's going to be 9.8 times 2, which is 19.6 meters per second. So the horizontal is still 20, and this is 19.6. So we'd like to have v, and let's call this one beta. So using Pythagoras, v is just going to be the square root of 20 squared plus 19.6 squared. So calculate that. So the square root of 20 squared add 19.6 squared is 28.00 meters per second. And then we want the angle, beta. Well, that would be the inverse tangent of 19.6 divided by 20. That'd be close to 45 degrees, I would think. So the inverse tangent of 19.6 divided by 20, that's 44.4 degrees, if we give that to one decimal place. With part C, there's a bit more to this. We're talking about the particle just here, just prior to it hitting the ground. So we think about Suvat. This time it's covered 50 meters. The acceleration is 9.8. The initial velocity was 0, and the final velocity is what we're trying to find. Now we can do that straight away. So v squared is u squared plus 2as. So there's not too much more to it. We don't actually need to know the time there or anything like that. So u is 0, and then it's 2 times 9.8 times 50. So 2 times 9.8 times 50, which is 980. And so v is the square root of that, which is 31.30. And what I would probably do here, if I'm going to give final answers to two decimal places, just make a note of a few more decimal places there. 31.30495. Okay, so we know that horizontally it's still 20. Vertically it's now 31.30. And what we want is v, and this angle here, which we'll call gamma. So v is going to be the square root of 20 squared plus 31.30495 squared. So that's the square root of 20 squared, add my last answer squared, and that will give me 37.15 meters per second. And then gamma is going to be the inverse tangent of 31.30 and so on over 20. So inverse tangent of 31.30495 over 20, that gives me 57.4 degrees to one decimal place.